Welcome to Web Handling. My name is Dave Roisum. In this video, we discuss spreading profile that is vital for spreading quality, especially for after-slitter spreaders. The word profile is a most useful and flexible word. It means the variation of something across the width. Almost always flat, uniform, and constant is way better than any other shape. Specifically, when we talk about spreading profile, we mean either the variation of CD stresses for unslit webs or the variation of gaps between slit lanes for slit webs. We can now define spreading quality as three vital ingredients. The first is the proper application details, such as was discussed in the spreading module of Web 101. The second is proper sizing, also discussed there. Finally, we discuss spreading profile here. It is no exaggeration to say that spreading profile and spreading quality are nearly synonymous, especially for post-slitter spreaders. An exception we will discuss in the next module is those very few spreaders that are profilable. Poor spreading profile is very risky, especially for rolls wound on the same axis. The risk is tying up two rolls so that they will both be lost. As web handlers might know, this process is self-exciting, as the webs will move to the high diameter created by the overlap, and this will cause the lanes to move inward even more aggressively, making more overlap. In any case, measuring profile is next to impossible for pre-slitter spreaders, but relatively easy for post-slitter spreaders. All we need to do is to measure the gaps between the lanes or the rolls. In many converting and winding applications, the gap might be around 1 millimeter as indicated below. Spreading power is simply the average amount of spreading. As seen in both set 1 and set 2, the power is the same, 1 millimeter. Spreading profile is the variation of spreading. In set 1, the profile is constant. In set 2, the profile has a problem. The middle and quarter point lanes are running together. Yet, even if we had an adjustable power spreader, such as the variable bow bowed roller, we would probably not be able to fix that problem. Trying to open up those lanes by pushing the spreader would probably make things worse. Only quality spreading and profilable spreaders have a chance here. The important question to answer now would be, why do I have a profile? There can be a number of possibilities. We have discussed baggy lanes in the wrinkling module of Web 101 and elsewhere. In the following slides, we will discuss spreader profile quality problems, including non-uniform curvature and diameter. There are other web handling possibilities, such as loss of tension, loss of traction, and so on, but such cases are beyond the scope of this video clip. Instead, we will discuss the first of two spreader quality measurements that you or your supplier can make. Desirably, the local radius of curvature is constant across the width. From geometry, you can calculate the cord to bow distance at various positions across the width. The spacing should be similar to what your minimum slit width would be. Of course, there are practical measurement challenges here, such as how to compensate for gravity, and how to set up the cord, and how to make the measurements that don't distort the bow or the cord. Here, you may need the guidance of an expert to speed up the process. Roller diameter variations can move lanes via the concave spreader principles we discussed in Web 101. In sliding, the lanes slide to the low diameter. In traction, the lanes pull to the high diameter. The net effect of either case is the same: the tendency to wrinkle unslit web and close gaps on slit webs. Measuring diameter profile is simpler, and the best of the machinists should be able to detect the hair's breadth variation that could cause problems in fussy situations. Sorting out the root cause, as many people would term it, requires a solid knowledge of web handling principles, close observation, and often some organized cleverness. Thank you so very much for watching this module in my Plant Practical series. If you want to reduce wrinkling and spreading problems, make sure that either you or your machine builder has gone to school.